Hi folks, should be live now. Let me hey JustRJS. Cool. That and oh wait, I'm already casting. It's just in the wrong monitor. There we go. And then let me go ping the Discord real quick. Cool. All right, we'll give people, maybe just a minute to get on because I was a little bit late. Sorry about that. Oosh. Second lovely stream in one day. This is the first time. I named this, what did I name this? Day 16B. I should go name the other one 16A, shouldn't I? We'll do that real quick while we're waiting for people to get on. There we go. Okay. Cool, can you hear me all right? Yep, cool. All right. Well, let's jump in. So we now have a means of running Linux, right? So we do this. Which is great. So I was thinking, I mean, long term, obviously, it'd be nice if this thing was multi-platform with different backends. So I was gonna name like this 2ASM thing really should be 2x86 64 Linux, right? And then in theory, we could have, different backends. Like I could do to, ARM64 Mac OS or something. But this is gonna be our first architecture we're building this for. So, yeah, what would be a good next step? So we're just gonna ask why 16B? Because this is the second one today. The first one was 16A, and this is 16B. So I don't know, it's the first time that's happened, right? So second, because it's still day 16, right? So let me just make a. We're just gonna make some really specific. Oh, why another stream today? Why not tomorrow? That's what you meant? I couldn't tell you why. I just kind of felt like continuing. And I've got the time today, so I don't really have anything going on. So I figured I'd do another one. I feel like we got some momentum going the first one, so kind of wanted to keep it going. Also, the first one was a little bit shorter, so yeah. Sorry, my schedule isn't very regular, which is kind of whatever. Yeah. So let's. All right, so this is going. I need a new instruction, right? So like a label, right? Because eventually we're gonna want like start, whatever, right? Oops. We're also gonna want something like global start, right? So let's do that. We'll call that like a global declaration or something, and it just names a label, and then I'll have a label. Do that. Oh, section. Would be that, right? Global that. Yep. 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 Could I just stick name in there? There we go. So now I have some more stuff we can deal with there. So if I have a variable decal, right, what does this come with? Name value, right? So like, I'm just gonna say if check expression data. If it's a function and the name is main, right? So this is like if we have a name function. Oh, this isn't how it works. Shucks. Is there a better way to write this? Oh. That would be better. Yeah, so if you have a function that's name is main, right, then we're going to um, that needs to be pop. There we go. This needs to be mut as well. Can't I do like deref? That's kind of what I want. Okay. And then in here, it's like instructions dot push. It'd be a label. The name would be start, right? What? Oh, deref mut. There we go. Hello, Felix Elijah. I don't know how to say the last name there. Yeah, this should work. And maybe we'd have comment too. So we can comment this. And then let's do that. So you can do that. Cool. And then yeah, is this gonna like work? We get start. Cool. That's great. It's almost working. And then, okay, so where should return values, I guess, go in RAX. So this thing literally the body is just that. Okay. How do I do this? Do I need a computer to do this? Can I do this with my phone? There are apps you can get on your phone. I know you can get Replit on your phone. It's just a lot slower. But in theory, I think you can use your phone. How can I do this? This thing is assembly. This thing is assembly. They both deref to a vec of instructions. What? Oh, like that. How are you making a programming language? Just by trying it. I just decided I wanted to, and now I'm just giving it a shot. Hi, I wonder if you use backspace or the arrow keys. I use backspace all the time. Like if I'm writing something, lorem ipsum, and then I hit N instead of M, then I backspace. Like that's normal. I never use the arrow keys. But I do use backspace. So this mutates, right? Okay, so now we have that. What's the base? What do you mean by the base? There's not any base. Like I'm not basing it off of anything really. There's nothing wrong with using backspace in Vim. In fact, it's the fastest way to, if you're in insert mode, it's the fastest way to undo something. So I'm not sure what they're talking about if they're telling you not to use backspace. But, yeah, backspace is totally fine, but yeah, try not to use arrows. My keyboard doesn't have arrows. So, see, there's no arrows on this thing. So that kind of helps. I literally can't. What did I just do? There we go. I was thinking of making a compiler in Rust and an OS eventually. Hey, that's what I'm doing. Will those be good resume projects for a systems engineer role? I have no idea. I've never... I imagine they would be. Like, seems like it'd be like the best thing, but I've never like applied for such a role, so I wouldn't know. when on the escape mode, you mean normal mode? It's called normal mode. When I like go at the end of a line and go to insert mode, it just doesn't go to the end but a character behind. It makes me use right arrow key. Like if you go to the end of the thing and hit insert, then you end up right here. Yeah, but if you do Shift A, then it appends to the end of the line. So try that, Shift A. Yeah, because if you go to end of line and then hit I, it'll have you one character in the wrong spot. So then you have to hit arrow key or something. But if you're over here and you just hit Shift A, then you're in the right spot. Or if you went to end of line and then hit A, it'd do the same thing. Because A gets you on the right side and I gets you on the left side. Yep. Are you making language that is interpreted by you and translated into another language? If assembly counts as another language, then yes, but no, just it compiles to assembly. So it's not transpiled, if that's what you mean. Yep, insert and append. Insert and append. I'm subscribing. Awesome, thank you. Okay, so anywho, we now append the body. Okay, and then I should get a to-do now if I try to do this. Not yet implemented functions. Oh wait. Oh yeah, so function. Oh, this should have been done in functions here. How far along are we? Not very far in the code gen, but we're type checking and everything with a basic subset of the language. Do I have a demo? No. Well, like a demo. What do you mean? Like it doesn't do anything really yet. I could show you like passing tests, but that's about all I could show you. If you go to the GitHub repo, you can poke around and look at the syntax and stuff. It's all in this syntax.lv file. So you can kind of look at some of the syntax in here if you're interested. The repo link is in the description. Okay, so this should have been down here. So maybe I should have some sort of flag. So some of this is going to be, yes, contextual. So I feel like I'm going to want pieces of state on this, which makes me feel like this should really be a struct called codegen. Yeah, okay, so struct codegen, I'm going to call this. What is the language made with? I'm making it in Rust. This is Rust right here. We're looking at the demo right now. Awesome. Oh yeah, this is the demo, exactly. So use codegen. It's gonna have, yeah, so like instructions. That probably makes the most sense, right? Instructions. That's pretty much all it needs for now. And then we'll import codegen and stick all these in it. Choink. And then this should take a mutt self. And then we don't need this. We can just do lines.push. Self.instructions.push comment text is generated by lovely. Oh, it need to be format. Like that. And then we will need that, but we'll hold off on that for now. Second stream, yep, second stream today. Is Rust a good choice writing lectures and parsers like compared to C++? I've never done C++, but yeah, I'd say it's pretty good and very popular for that. Just like Mr. Glick said. The standard library in Rust is amazing. So yes. Will you make a tutorial on how to make NeoVim look like mine? I could. We could do a stream one day of me rewriting my NeoVim config. That'd be fun. What's this? This would be self. And then come again? Oh, this needs to take him at self. So this doesn't really need to. Should this return assembly or just add to the instructions? Probably just add to the instructions, right? So it doesn't actually need to return anything. And then, oops. We have a name for this. Okay. I would love it. I started using NeoVim today. Nice. Yeah, NeoVim's great. Alright, so that kind of works. And then self dot. Oh. Okay, new plan. This actually should return assembly. I'm thinking. Is there a good? All these warnings are stressing you out? Do you mean all my Rust warnings like those? Okay. So we're gonna. This should sort of work. I feel like, maybe. So let's go in here and fix this. We need a way to create a new one of these, right? So something like that. Okay. That, and then, well, that's actually fine. Cool. How far along are you in the codegen? Did you start in the first stream, Mr. Glitch? I've basically done nothing. I basically most of the first stream was setting up this little Arch Linux VM so I can run it on x64 Linux. See? So no, I haven't hardly done anything with the codegen. All right, will this work? Okay, now you implemented functions. That's what we want, right? Functions right here. Okay, so that's our problem. Here we go. Perfect. So I'm gonna make okay, so I'm gonna make a flag here called like is main. And then set is main to true, and then why don't you make a small bash script? Well, I can knock this down to one command if you really want. Like this. How's that? Okay, so then we set that to true, and then we pretty much just went to right, the value. What does this give me? Assembly? Okay. Check out the cow struct for ASM generation. Copy on write, isn't that what that is? How would that help me out? So we have assembly, which this should in theory go to here, right? And then yeah. Cow can contain either a static str or a string, so no string allocations for string literals. Why write Rust when you can Zig? Because I don't know Zig, and when I did learn a little bit of Zig, I didn't like it as much as Rust, but so now we can do that. Right, we should be in here now. So yeah, functions were in here. We should have is main true. Perfect. And what are we getting as our output? Oh, that's no good. Comments don't need to have this. So it knows that it's the main function. So I'll say in here if self.isMain. Exactly, Andrew. Why write Zig when you can write Rust? If there is main, then I guess we'll do like instructions.push a label, right? Which is start. Oh, is this why you want me to use cow? So that I don't have to do this toString thing? Is that what you mean? I done? I don't think cow would actually help much since so much is generated. Okay. That's right. This will be fine for now. So we push start. So this should work. Yeah, we push start. Groovy, groovy. So then, how do we tell it to push? Okay, so this all needs to be in the text section, right? So we need some notion of sections. So let's have like a text section, or yeah, maybe text. I don't know. Struct sections, text, string, and then like the top. I feel like I need to look at some assembly again. That'll be the one we need to worry about right now. And then the very top, I guess. String. Let's just do those right now. So then instead of instructions, oh, it's not string though, it's assembly. Assembly. And then instructions, no. Sections would be sections. This would be sections like that. Self dot sections dot top dot push. And this would also be self dot sections oh, how to make this work? This will go to text, right? self.sections.top.append. Oh. What? So append doesn't return. So what's one that like would? Well, I guess since it's okay, so maybe it is append we want to do. And then we just do. That's a little messy, but it should work for now. Okay, does this still work? Very nice, okay. I still feel like this maybe shouldn't return assembly, but should rather yeah. Okay, so codegen expression, we'll just do that. And then instead of this, it'll be this. So we don't need this. It'd be like self dot sections dot text. Does this still work? Perfect, okay. And then if it is main though, we also want to append to the sections.top something that says like global start. Sweet. That's very nice. Okay. So this would, we can even push a comment here that says like, why does this comment have this? Section can just be a that. What about function definitions and function definitions? Do you just jump over the generated function? What do you mean by jump over the generated function? I'm not sure I get that. Label also should just be a string. All these ones that are just like that. There we go. You jump over function definitions in your lane. Okay, and then over here, this just can be this. Maybe bad for stack traces depending on the implementation. Well, yeah, we'll see what happens. That made that at least a little bit more terse, except for I still have errors. Comment can just be this. There we go. But I wasn't gonna do a start. I was gonna say main function. Cool. And can I do self.sections.top.push? New line. Can I make like a new line instruction? There. Now we should get a new line. Why are there two new lines? Oh. Because I'm already adding new lines between them, so it should just be an empty string. Very nice. Okay, so now there's just that. Lovely. Okay. And then we'll do it after this. Awesome. So then we need to do the bot. So what do we have here in the function? Parameters, return type, body. Oh, this needs more data. I'm not sure if I like how, like when we make this, it's kind of weird API, right? When we make a checker and then we check a program, like this gives us a checked program, but also mutates the checker and just sticks the well, maybe that's fine. What if new just took an AST? I feel like that'd be better. I feel like that would be better. Checker. And then it just had like a check. Yeah, this would be better. Okay, so checker is gonna hold on to an AST. Or better yet, checker just could hold on to a parser. How about that? Oh dear. Okay, and then why day 16B? Because this is the second stream today. So first one was A, this is B. Or do you mean why am I doing 2 in one day? Which do you mean? Oops. Wait, how does this work? So we'll give it a source, which is a source stir. Wait, does that make sense? And then we make a new parser like that. Lovely. Are you self-taught? It sort of depends what you mean by that. My uncle taught me a lot, mostly about web development at one point. Otherwise, I've learned from, yeah, books and videos and tutorials and stuff. Hey, ICXD, there's our compiler dev guy. Our resident compiler developer. So what I'm thinking is that this should have, don't I have check scope? Where's my actual check program is, okay, this is the thing that's out of date. So I want this just to be check. All right, I don't want you to take a program, because that's ridiculous. I want you to say, let ast equal self.parser.parse. So you just do it right here on the spot. And then here we can do this. Oh. This might error. Well, how does the parser work? Because the lexer can error, can't it? Oh no, because it just uses the lexer. Gotcha. So we'll have a checker. Okay, so error is gonna have a new, it might another kind. Okay, so it could be from parser too. From parser, which holds on to a parser. Parser error. Did you try Odin Lane? No, I haven't tried Odin Lane. What are we doing today? We're trying to do codegen, but I just realized there's a little API thing I didn't like, so I'm just tweaking this real quick. So the checker, parse. So check can error, I suppose. Or not. Well, yeah, okay. Let, okay. Love codegen is the best part. Sweet. Yeah, it is similar to Odin's language. Odin's syntax, I mean, sorry. Else we'll do self dot type errors dot push. I don't know why this is called type errors at this point because they're not all. You do suggest adding some sort of IR though. What sort of IR? Oh wait, hold on. Is that good? Oh, span. Parse errors don't have a span. Generating assembly directly from the AST makes it incredibly difficult to add optimization passes later. What's TAC? TAC? Three address code. What does that even mean? Look it up. All right, let me just fix this real quick. Has a Wikipedia page. Okay. This needs a span. I guess I'll just for now make up a span. Like span joink star 0 and 0. That. Okay. So then there's that, and then error from parser error. Oh wait. Oh wait. Wait, I need to get the error here. How do I do this? No. This isn't the greatest. This would then become this, right? That should do the trick. Hey, Robin. Welcome. All right, so now that API should at least be nicer. Okay, those are from the other thing. Tests are broken. So now this needs to take a parser. Use the input again, right? And then wait a minute. That didn't solve my issue. Well, I guess that's fine. Okay. That's all right. So then checker new needs to take, we don't actually, we have a file source, right? So we say file source. We don't need that. And then you say check, and we don't need this. All right, let me just, hey, is anybody there anymore? Yeah, I think lightning struck and we lost internet for a second, and now we're good. So I didn't do anything without you guys. You thought it was you? No, it was totally my bad. Yeah, there's like a thunderstorm outside, and there was a bang, and then the internet broke, and so. But yeah, it's working again. Sorry about that. So where were we? Hey, we got an illegal global expression error. This is great. Kind function call, name add. Oh, our tests are all failing because we made non-constant global expressions illegal. Okay, that's fine. But at least it means it would be working. We just kind of need to change them to be inside of main functions or something. I don't know. Okay. So my bad. Oh yeah, I guess it wasn't my bad. Is it just me, or is my webcam like really fuzzy? Does this make it better? How's that? Yeah, it's about the same. Okay, maybe it's just the lighting. Why is it showing the wall behind me now? Whoa. Come on. There we go. Okay. What was I gonna do? I was gonna look up ICXD's thing, TAC. What is it? 3 address code. Do I have a browser up here? No, I don't. Shoink. 3 address code. Three address code. A 3 address code, often abbreviated as TAC or 3AC is an intermediate code, used by optimizing compilers to aid in the implementation of code improving transformations. Each TAC instruction has at most 3 operands and is typically a combination of assignment and a binary operator. The name derives from the use of 3 operands in these statements, even though instructions with fewer operands may occur. How do you use this thing? Since the 3 address code is used as an intermediate language within compilers, the operands most likely will not be concrete memory addresses or processor registers. There's an example. Oh, like this. Calculate one solution to the quadratic equation. Okay. So you say b times b, which is this, and you do 4 times a, and then you do that times c, and then you do that minus that, and that gives you this. And you do square root. Oh wait, but this one's not 3. So like, what about this? Did it freeze? It did freeze. Can you hear me though? All right, 1 second. It's our every stream. This happens 1 time. At least I'm getting pretty fast at fixing it. Do that, and then that, and then that, and then drag that into the corner. And then make it their full size. And then add me back in. Where am I? This guy. And then do that and that. And then shrink it down to, oops, not that. Shrink this down. Like that, and then hide it behind that, and hide that behind that. And then go up here, and OBS should be like this. All right, problem resolved. It doesn't exactly have to be three operands. That's just how most instructions are. Like this one's just 2 operands, right? Okay. Oh, so what about this? Because this is kind of different. This actually really makes sense. It's pretty simple. Yeah, it is pretty. It does seem to be pretty simple. So you basically just turn everything into something that ends up looking like this. And then this ends up being, yeah, it's literally just an IR, right? And so then you translate this into assembly, which is should be really straightforward, right? And then that also would make it easier to make different backends too, right? Is that one of the other benefits? Because once I have this, then this is pretty easily translated into like ARM or Linux x64 or Humble x64 or whatever. So that's really interesting. All right, you pretty much sold me on this. I like this. You say exactly? Okay, cool. So, oh, cool. This is like this is the best Wikipedia article I've ever seen. It's literally only this long, and it has 2 examples. I wish all of Wikipedia was like this, because I generally don't really care about the history of the algorithms. Okay. Gonna do the Arch64 backend? What, you're saying you're gonna do the Arch64 backend, or I should do the Arch64 backend? I'm taking contributions for other backends, by the way. And yeah, you should totally do it, man. I'm gonna try to set this up, because obviously, like, the Humble. See, I can't even write it for Humble initially, but to keep it as similar to Humble as possible, I'm gonna do it for Linux, x64 Linux, right? And then, but I'm gonna try to keep it set up to where it'd be easy to, like, you know, add another backend. So just, you've been doing lots of ARM recently. That'd be so fantastic. And it should be pretty much just, if I already have the TAC stuff set up, it's just a matter of translating that. But let me try to resolve this flickering, because it looks like I'm flashing. Hold on, come back here. Usually it takes 2 tries. Okay, looks like I'm not anymore. So we need to go to TAC. Is TAC, you can write a little sample for the TAC implementation if you'd like. Well, I can give it a shot. It doesn't seem too bad. Oops, I'm guessing I'm not literally going to like a string that looks like this, right? It's probably some like in-memory representation, right? Because that seems like a waste of time to generate this string. Hold on, you'll send me an example. Okay, that'd be great. On Discord, sure. Reading IR/CFG or directly assembly like output. I guess we're making an IR now using this 3-address code, but it's still ultimately just to directly create assembly. Just my opinion, but for assembly using RISC-V would be much easier. Yeah, maybe, but that's not what Humble is going to be, right? And ultimately, Humble is kind of my goal. But we can have lots of backends. Okay. Gotcha. Okay. ICXD, I see your thing in Discord. What's the what in the world is temp ID? Like, what's that representing? So let me go in here and make a tac.rs. Make this be mod tac. And then I'll have, yeah, pub enum tac. Okay, yeah, so you have like add. Oh, gotcha. But what is the temp ID? Like, what is that representing? Oh, just a variable. Okay. But what do we if we don't know the type of that variable? Sorry, for those of you on YouTube that are confused, there's a chat going on in Discord right now. Like on the Wikipedia article, you can see. Oh, like the B and B here? Oh, these guys. These stand for temporary. Okay. Okay. That sounds good. We can do that. I do not know what SSA is, Robin, but it sounds like ICXD does. Single static assignment. Oh, does it mean that you just turn every piece of code into a series of single static assignments? Is that kind of the idea of SSA? And then TAC is just one variation of that? Look it up. All right, we're gonna look it up. SSA. Wikipedia. Social Security Administration. Means a lot of things. What did you say it was called? Single static assignment. Single static assignment form. And compiler design, the type of intermediate. Each variable is assigned exactly once. SSA is using most high quality optimizing compilers. Oh, this is going to be a high quality optimizing compiler, so we better use it. It's using LLVM. Gotcha. So it is pretty much what I said, right? You turn everything into a series of static single assignments. Very interesting. Swift uses it, Erlang, LLVM, Go. Looks like everybody's doing it. Can be a bit complicated to get right, but it pays off. All right, that's okay. I'm down for complicated. So we're trying to make things that fit this form, right? And so everything has a, well, everything has a destination. So I wonder if I could do this a better way. Like, what if I made this be a struct? TAC, and then had like a destination or dest or something. Dest is always one of these temporary variables, right? I'm assuming. It allows you to perform stuff like dead code elimination. Gotcha. Not always. Oh dear, now we're moving back and forth between YouTube and Discord. Look at the examples. What? So X is different. You mean like X here? Okay, these point to, oh, last example. Oh. L1? What does this even mean? Copy it so you can read it properly. Oh, is it not? Oh, that's a lot better. And then, okay, perfect. I'm gonna do that, and I'm gonna do, well, this came from something like this, and shoink. Oops. That turned into that, and then this turned into this. Shoink. All right, this is very well, very well. I don't, oh, okay. What's this whole star T4 business? Store through pointer? Oh boy. Okay, so this can get sort of complicated. This is so interesting. Okay, so it doesn't necessarily, so that's why this shouldn't be like that. Okay, gotcha. So add would be something like, yeah, so dest would be like a temp ID, kind of like you said, right? Which is something I need to say up here. Temp ID is just a usize. That should probably be pub. Well, I don't know yet, so we'll leave it. And then we'll have like a left-hand side, which is like some value, right? Oh, that's what you had there. Some okay, value. We'll do that. So value, pub enum value, right? Except these should be values. And the destination on an add is always going to be a temp ID, I'm assuming, right? Or should that just be another kind of value? Probably just another kind of value. Temp ID. That doesn't make any sense. We'll just do this. So this can be a value. Okay, and then what else can we have here? We can have add, basically all the arithmetic things, minus, multiply. Destination will always be a temporary. Okay, so maybe we should divide. Add sub mul div. Is that better? Sub mul div. So let me pull then out type temp ID actually and do that. And then this could be a temp ID, but then we can just say that these are always temp IDs here, right? Oops. That works, just convention. Okay, gotcha. So we have that, add some mult div. What else do we have down here? We've got squirt. I don't know if we need squirt yet. We'll just hold off on that. We can just have a direct assignment. So, okay. Like what is this assignment? Well, the destination isn't a temp, like this isn't a temporary ID. This is a, but what about like type information? In Runestone, you have a copy and a move. Okay. Yeah, what about type information? Because like when I get to, if this is all I have when I'm generating assembly, how do I know that X is, you know, of type, of whatever type it is, you know? Like, do I just kind of lose type information? Add types. Do it LLVM. What's LLVM style look like? I've never done that. Like add types to all of these, like values have types associated with them. Is that what you're suggesting? Because that would make sense. Yeah, okay, so value, okay. So I'm gonna say, I'm gonna change this, I guess, to struct like entity or something, which has a value, which is a value, and a type, which is a type ID. What is type? Any single value is a type. Okay, that makes sense. So I really only need. Okay, so another enum called type. So every entity, I can't do this, has a value and a type, right? And so this is like, these are all my types right now. Eventually this int is going to be split off into obviously a bunch of different int types. But at the end of the day, everything is somehow one of these, okay? Okay, this is cool. So what else do I have in here? Assign takes a destination, which is, oh, this is all messed up now. Okay, so left-hand side is an entity. Right-hand side is an entity. Destination is a temp ID, right? I think, although it does kind of need to have a type associated with it, doesn't it? So maybe this should be a value too, or like an entity. Does that make sense or not? Nope, it doesn't need to have a type associated with it. I feel like it does. Yeah, make it a value or an entity. Yeah, that's what I thought too. So now all these become just entities. Joink, joink, joink. Same with assign. And then anything else in here I need to know about? Okay, there's optional conditional jumps. Oh dear. These get complicated. Okay, so there's labels. So can my labels just be like their own thing? Like have label be here. I feel like this is a little cleaner. So labels are their own jam. Okay, so label is like a new thing. Label, which can it just be a string, right? It just needs a name, that's all it needs. And then I have conditionals and I have go-tos. Okay, so go-to is a thing. Go-to takes a string. And then I have conditionals. Conditional, which is a little bit more complicated. Okay, so we need like a left-hand side, which is an entity. We need a right-hand side, which is an entity, and we need an operator, right? Which is an operator. I don't know why I call it operatory. Hey, Jappy. Less, greater, less, equal, greater, equal, equal, not equal. Those are good. And then this kind of limits these things. Like what if I want to do something like this? Should I make this like big and recursive? I've heard you started code generation. It's sort of true. I'm working on an IR now. They convinced me to make an IR. ICXD, do I want to still be symbol form? So there's only ever going to be like right hand side, left hand side, and middle operator. I'm never going to need like, or like if I have this in code, am I going to be able to represent it, which is something like this? Yeah, okay. All right, we'll try that. If it breaks, it breaks. So we got a left hand side, a right hand side, an operator. No. Multiple conditionals. Wait, so I do need to have multiple conditionals. Come again? Multiple conditionals as in what? Something else here? So left hand side, right hand side, operator, and then it has like multiple conditional jumps. Oh, so we just break it apart into like jump to here, and then if that, jump to here, otherwise jump to here. Okay, gotcha. I'm getting a phone call. Let me take this real quick. I'll be right back. Okay, I'm back. That was like the strangest phone call ever. Somebody wants me to play with their like music group. Okay. Yeah, lovely customer support time. No, it wasn't. Sadly, it wasn't lovely customer support yet. Okay, so where were we? Oh yeah, conditionals. So conditionals then are followed by just another line, right? What are these called? Ooh, SSA it? Yeah, that's what we're doing, I think, right? Single static assignment. Sorry. You're programming and forgot you were watching this. Whoops. Okay. Oh, what is this called? Like, what are these? What's one of these lines called? Like a TAC line? Should I rename this to a TAC line? Line TAC line. This needs to be boxed. Honestly, kind of startled me too. Instruction. TAC instruction. Sure. Instruction. Instruction's good. Is making your own programming language hard? It's not super trivial, but it's been really fun, and that kind of outweighs the difficulty. So, okay, that's pretty much everything I've got going on here, right? We have labels, we've got conditionals, we've got go-tos, or you could just remove TAC. Ooh, fair enough. Before I forget, let me write down the dates that this person told me for this thing. What was it? June 22nd, right? There's June 22nd and 29th, and then July, what was it? July 13th and 20th? Okay. Got it. Okay, now we can continue. Go-to is goat. You like go-to? Usually they have a condition, true label, and false label. Oh, like an else? Is that what it is? Is the false label like else? Oh, so you're saying... Oh, so they just do go-tos? They don't have like an entire instruction right in here? They just have labels? So I couldn't do like... Instructions are bundled into a so-called basic block, which has a label and a list of instructions. Okay. Wait, so should I have this be able to be anything? Like, could this be something like this? Or does that not make sense? It does have to be a go-to. No. It has to be a go-to. Oh, okay. So then I did this totally wrong. This has like a true branch, right? True label is a string, and a false label very good answer, Robin. Thank you. True label, false label. This is cool. All right, this should get me pretty far. Right? So then we just need to basically get rid of everything we did. So I'm going to change our codegen. I'm going to say yeah, so this is kind of should I make an entire new like section in here? Like IR? I think I'm going to. IR mod.rs. And then in this thing, TAC should go in IR. And this can be done. Mod TAC. Okay, I see what you sent me here. ICXD. Wait, what is a basic block? Oh, runestone. Runestone's way beyond me. Just look at how the instructions works. Wait, isn't that... Wait, are these different from like my instructions here? The like your instruction, you have like a ret. I don't have a ret. Should I have a ret? Should I have a ret? Ret is just returning out of a function. Yeah, is that something that you end up having like in the TAC? Yeah, it is. Probably. Here we go. This thing? And then line 228, this thing? Instructions. Shout out Stefan for docs. Yeah, this is nuts. Did he literally write all this? Good grief, what a guy. Stefan's crazy. Okay. Also, please use box stir if you're using immutable strings and struct fields. Why is box stir better than string? I'm curious. This? This thing? You got more coming? Do you work for yourself? Is that where you're able to stream for such long amounts of time? I do not. Well, this is for myself, I suppose. But no, I work with my uncle. But definitely not full time. And it's pretty low key, so I get to choose my hours. And it's, yeah. Another one. Yeah, it is really cool. I enjoy it a whole lot. Making sure all the basic blocks terminate at some point. Okay. Because they need to. What is a basic block? That's what I don't really understand. What's your whole basic block ideology? It's this. This? It's just a labeled list of instructions. Like what would, like, for example, what would one represent? Like, is this a basic block right here? This is a labeled list instead of having just random labels. That makes sense. Yes, okay. Go to is a terminator. Oh, so a basic block. Oh, I think I get it. I think I just had one of those aha moments. So a basic block, rather than just like running, like stringing all your code together into one giant long thing that's really hard to reason about, you break the thing up into basic blocks, okay? Basic blocks need to end in a terminating instruction so that they're all disconnected from each other and you can sort of put them in any order and they just jump around from one to the other. Is that it? That's it? Okay. I'm getting some positive feedback in the Discord. That does make a lot of sense because it's kind of going to be a headache if you just have to string the whole thing together in like the perfect order, no? Okay. I get it. And then what? Jappy gets it too, yes. For those of you not following, yeah, okay, Robin. A block you can jump to via go to and has a terminator. Yeah, gotcha. You had a concept of functions, which has a name, parameters, then a list of basic blocks. Ooh. Gotcha. Okay, big brain move. Wait, so Robin, you're saying the then branch and else branch of an if statement could be two basic blocks, which is functionally the same as two labels, right? Because labels kind of identify these basic blocks. I like this. All right. So then there's nothing to do but implement this. So should I rework this? Like, this has a true label and a false label, right? Should these still be labels? What happened to my LSP? Oh, that's what happened to it. This, I need a mod IR. Okay. So instruction. Okay, so a basic block. So I need to make a basic block kind of thing in here. This is very interesting. Very, very interesting. These I feel like should be down here. Joink. All right, so we have this concept of a, this also should probably be down here. Shoink. Please use box stir instead of string if you can. Why? Could you explain? So I have a pub struct basic block, which has exactly this, right? A label and instructions. And then in here, instead of strings, I could just have a basic block. So, or a label even. Well, do I even need the label at this point? Remove label, that's what I was gonna say. Can I just remove label? Just pass basic blocks here, basic block, basic block. Lovely. And for goto can also be a basic block. Sure enough. This is good, this is good. So then, string has a capacity field which you don't need if the string is immutable. Box stir is just a slice pointer. So you're telling me it's just like more efficient or something? Except I kind of got rid of all my strings. So now we're good. Oh, except for this one. Oh, this is just one, right? Surely this isn't gonna hurt anybody. You think I should do this? I think I'll just leave it like that for now. I think it'll be all right. Okay, so this is cool. So let's go work on this, right? With loops, you can go crazier where you have like a loop entry and a loop head and a loop body and a loop exit, and those are all blocks. Sounds like Robin gets this. Okay. I'll get to loops when we get to loops. We don't even support loops yet, so it's all right. For now, we just need to take a, yes, what do we need to take? So I'm gonna make I don't know, struct IR. You might want to do something like basic block ID, then pass that around instead of actual basic blocks. Oh, like I did with type ID. Yeah, that does make more sense, doesn't it? I like how you guys are just like using Discord like you would the YouTube chat. It's kind of funny. Everybody who watches this video later is going to be totally confused because they're not going to know what you're saying, but it's all right. So, okay, so struct IR is going to have some sort of like, you're typing here, but Discord has code blocks. Fair enough. Yep, code blocks are good. No, I'm not complaining. It's good. So IR will just have some sort of, okay, yeah, so impl IR. Some function that's like generates an IR, right? So create TAC. Which returns Usually I call it like context or module. Imagine if you could mark a Discord channel as your YouTube chat, so you could write there and it's like synced. That would be really good. They should just make like a streaming platform for developers. There's a business idea, people. Whoever's looking for a good startup idea, there it is. And if you don't do it, I'm gonna do it. Okay, what are you suggesting I call context or module? This whole IR thing? Context? Like this? Create TAC. This creates a TAC? It's pouring. What is TAC? It creates a basic block. Is everything? No. What does this create? So it creates a list of basic blocks. That's easy enough. Vec of basic block. And this is to do. Generate TAC. Streaming platform and lovely one, yeah, totally. You're gonna make billions on my idea, ICXD? I didn't know you had the ability to make user-facing interfaces. Everything I've seen you make is like languages and compiler tools. You snooze, you lose. I'll raise you. You have no idea? No, seriously, I'd use it. If you make it, I'd use it. Alright, so create TAG, this is cool. We want to user-facing interfaces. That's my new quote. Okay. Anyway, back to the work at hand. This stream is nuts. So let me make the this guy. Okay, so he's going to, what does the IR hold onto? It's gonna need a checked program, right? Yeah, okay. So context is gonna need a checked program. Okay, here's my problem. Can you counsel me here a little bit, ICXD? Because I have, check this out. Where does this go? Okay, checker. Here's checker. I don't like its API, okay? I have this function, check, that returns a checked program, which, I mean, that makes a lot of sense, okay? But then check also mutates. So like both it returns the checked program, which is like a checked program, obviously, but then it also mutates these things and just like adds all the scopes and types and variables and errors onto this thing. So like at the call site, you end up doing this check thing, but then you also have to like check the things that are on the checker that you checked. Does that kind of make sense? You don't get it all in one big bundle of joy and happiness. Let me know if that didn't make sense. And I'm looking for a better API. Here's like an example. I make a codegener. Makes no sense at all, love it. You have a codegen, which you create, and then you do codegen. Sorry, this is the total wrong thing. I don't know what I'm talking about. Checker, you create a new checker, you pass it the file source, okay? And then you do checker.check, and then you get a checked program. But that just has the checked AST. That doesn't have all the type errors. It doesn't have all the variable definitions. It doesn't have all the types. It doesn't have all that stuff. To do that now, you have to go on checker and then look at all these things on here, right? And so that's my bad API. So like it makes a type table, but the type table is in the checker itself. Exactly. Which is no bueno. Right? I mean, I think it's no bueno. Checker.check. Yeah, isn't this a good API? You should get a program and a type table. But then what about type errors? Where do type errors go? Then make compile return result vec error or whatever. Come again. Come again. Look, checker.check doesn't have error. There's no errors here. Because if there are errors, it pushes them into the self.type errors. Make the user handle it. Hold on, people. Hold on, people. I'm gonna make a server. I mean, not a server. I'm gonna make a channel for this because this is ridiculous. Where should we go? I don't know. Here. Actually, I'm gonna do it here. No, I'm gonna do it here. Here we go. Text. Stream chat. Shoink. Okay, go to stream chat. I think it's for liveness analysis. Oh, that's for, okay. Thanks for saying the link, some person. All right, did I get a good suggestion? Let me go back to the other. Return the type errors. But here's the thing. Here's the thing. Get this. So if I have type errors, I don't just want to return the first one I come across, right? You return the entire vec, exactly. Oh, I get it. I think I get it now. Okay, so you're saying do this. You're saying do this. You're saying do this. Result. You got to go to bed or you got to get in bed. Those are two different things. Like this. Vec of error. Get in bed. Okay. Exactly like this. Okay, but then what about, so that kind of solves this type errors problem. It is genius. I know. It's almost like there's a, what about these variables and these types? Because I'll probably need these later because I need to like know what the types are. So what do I do with those? Do I make some sort of like output struct that kind of holds all this stuff together? Like a type table or something? Like what if I did this? How about this? How about this? What if I have a, leave it as it is? If the checker owns the parser, the IR generator could own the checker and so on. Fair enough. Fair enough. All right, so we'll get rid of this whole type errors thing. And then this doesn't exist anymore. And then, all right, ICXD is gonna be right back. Oh, this makes it way better because then you get either a list of type errors or an AST and not both like I was before, which makes a lot more sense. Okay. Type errors. So we don't do this. We'll return You figure out the point of the result type? I didn't know what the result type was for. I just wasn't using it. Okay. So what do I need? I need some sort of like let mut errors be a vac, and then here check expression. For each expression, you're gonna return yeah. I'm sad there's no anti-result or success failure type. Bool exists, but it's not the same. One thing you could do, scope creep, is use some kind of CST, concrete syntax tree, where the invalid parts are marked as invalid, but the rest continues to type check or whatever. Could be useful for LSP so you can get info on syntax highlighting or format is working. Very interesting idea. Coding in bed, life's good. All right. I think it already skips the bad parts to move on. Correct. More or less, sort of. I mean, yeah, kind of. But it doesn't do it at a really deep level. So like if there's like within an expression, like it only does that at the level of top level expression. So if it gets to a top level expression and it finds a type error, then just bails from parsing that entire expression. And it won't like try to parse the rest of that expression. So it sort of does it, but not totally. Exactly, that's why there's a VEC of errors. But it could be better. But for now, this will be fine. So your point is still valid, Robin, because it could do that to a greater extent. So what am I doing here? Okay, so this needs to... What does this need to do? Okay. Wait, so this is bad. Then we need to return. Then we have a parser error. So right, we just return error vec like that. That's cool. All right, and then in here we'll say. Wait, do this. Check this out. Drunk. Here, if this happens, we will say errors. And then here, we'll say like if error if it's not empty, then return that. Otherwise, here return okay. Ta-da! Okay, so this should do the trick. In our checker. Bro's getting so sidetracked. We're like 3 rabbit trails deep. Hold on, here's what you should do. Stretch, drink some water, continue. Any stretch recommendations? I got water right here. Okay. I will take stretch recommendations. I have a yoga ball in the room if that helps. Where were we? This is what happens when you get 3 rabbit trails deep. Backflip on the yoga ball. Ready? Like balance on the yoga ball and then do a backflip and then land it on the yoga ball? I might need to practice that first. Oh man, you guys. Okay. I came into the stream while you were getting sidetracked, so I want to know. Yeah. Makes sense. Here, listen. So we need... I literally don't remember what we were trying to do. Oh yeah, we're trying to do this thing. Okay, cool, cool, cool. So then this returns the back of basic blocks. Oh, that's very great. A basic block should have some way to like... Here's what we should have. Okay. Impl instruction. Or isn't there like a... Okay, impl display for this instruction. We need to do that. Okay. And then do this. And then do this. And then do this. Except for we can literally do the same thing for all of them. I just wanted this logic right here, actually. Use this right thing. What is this? How's that? Okay, perfect. Right does not add a new line automatically? Okay, thank you. Copilot coming in clutch, yep. That'll do nicely. Okay, so then we'll have a same thing kind of on here. Impl display. This good? Right. The label on here, and then you do all the instructions. Perfect. And then this is good. Look, we do another one. No, not this. Just one more new line at the end. Perfect. Okay. Do right line. Oh. Right line. Brilliant. Brilliant. And then we'll do that. Keep that one. And then here, right line. Great. So now we have that. So then here's what I want to do. I want to say, go over to here. Everything's broken. We're going to get rid of all of this. Shoink. Okay. And then we're going to... We're going to what? We have a checked program. Wait, so how do we make one of these things? Create TAC. How do we make a new one of these? Okay. New self. We create one, and then we have to create. Okay, so this needs to be pub. This should have a new name. IR generator. Except for in Rust, you don't usually do this, do you? Although I kind of like it. This should be pub. This should be pub. And then okay. So we will now okay, I guess you can do that. Now we go over to the main, and then down here we make a let IR generator equal IR generator new. So now we have one. Then we're gonna say let IR equal IR generator. Oops. Dot create TAC. And then we're going to print line to string. Uh-oh, we can just do this. What? Oh. 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 Emitter.mat block.toString that. Very nice, very nice. This is the main, exactly. Okay, we got it. So then, let's try it. What is this? Okay. Not yet implemented generate TAC. Perfect. So then we jump over to here. We just got to fill this in. It's so simple. It couldn't be simpler. So does this guy hold on to his own checked program maybe? Checked program should be a checked program. You pass it a checked program? Better yet would be if you just passed it the source file and it made that itself, no? How would we do that? Source is stir. And then you're gonna say, I might need a lifetime for this, but it's okay. Let oops. Create a new checker. Now we have a checker, and then we do you get this. Oh no. This can error. This is bad. Oh, there's people writing in YouTube. Who knew? If needed, write line, do write a new line. Oh yeah, got it. Thank you. Hi, what font are you using in your terminal? This is Maple Mono. Oh no. I'm back. Can you guys hear me now? The internet died again. It works again. Okay, cool. We're back. All right, so what were we trying to do here? Oh yeah. So we got a check program. Oh yeah, so the check program might error, which is kind of annoying. What should we do? Unwrap. For now, expect. I'll say, you know, the program didn't type check, silly. And then in here, we can now say this. Joink. Okay. Cool. Very cool. Nicely, beautifully formatted errors. When? Soon. I mean, maybe not very soon, but eventually. I mean, for sure, at some point. Yes. Everything has to be lovely. Hello, the coding youngster. You went out to the type checking and a codegen related part of the code. Well, that's kind of how everything is working at this point, right? Like the the everything just takes the source. And then does its own. I mean, I could keep them all separate. But the parser already owns the lexer. And that kind of is a necessary thing. And so the checker doesn't need to own the parser. And the generator doesn't need to own lexing and parsing is on the same pass. Exactly. Yeah, what do you guys think? Should they all own each other, or should they be separate? We got people writing things. Right now they all own each other. I could make them separate. Personally think I should separate. All right, everybody says separate. All right, we're gonna separate them. This means we have more work ahead of us, but it shouldn't be that bad. Okay, so here, basically, but you're cool with the parser owning the lexer, right? Because that's kind of like the same pass. It's one cool thing. So, we got a lot of pro separate. Okay. Parser owns the lexer. Who owns the parser right now? It's checker. Okay, checker, you're fired. You don't not any longer get access to this parser. So you don't own parser. What is he gonna do if he doesn't have a parser? All right, parser, no sir. No sir. You no longer need to take that. You no longer need a lifetime. Everything just becomes simple. Everything becomes simple. Oops. Self-top. There's no self-top parser anymore. What does it get? It's gonna get past an AST. AST is gonna be a program. This guy. Shoink. And then we don't need that. Lovely. Uh-oh. Maybe add a compiler that calls all the passes. Sure. Fair enough. Although that's just gonna be like in our main. So at some point, yeah. Something like that. That does make more sense. Checker.check AST. Wait, what's going on here? Oh. Wait, what? Oh, because we don't handle parser errors anymore. Oh, this is great. So we go over errors, and we don't have to worry about parser errors. Cha-ching. And cha-ching. And go over to here. And we no longer do this. There's now no longer this case. We don't even have to match on this thing. We can get rid of 2 sets of swirlies. And we got other issues. We don't need to pull in the parser. This is causing errors in other places. Okay, and then the IR guy, this guy doesn't need to own his own check pro. Wait. Create TAC should just take a checked program, right? I guess. But we don't need to do this whole dance down here. New, you get for free. Ta-da. Okay. And then, yes. And then, codegen, we're going to come back to later. That's kind of, what in the world is going on? Okay, so then we got to fix things in here. Everything's kind of broken. This is good. Checker.new doesn't need this. You check the AST. Very nice. Very, very nice. Okay. Main. You don't do that. This, Oh, this is different now. Okay, so we need to say let lexer equal lexer new from the file source. Oh wait, I take that back. The parser owns the lexer. Let parser equal parser new file source. Does this mean I was right for once? Not for once. Yeah, you were right. Parser's a trait. What are you talking about? What is this guy? Oh. Hold on. Use parser as lovely parser. How's that? This becomes lovely parser. And then we make a new checker. Shoink. Import checker. Then we check the we gotta say let ast equal parser dot parse. I guess. Mutt. And now we have that. Checker dot check. This takes an ast. AST IR generator. Yay. Clap has extra crates for shell completion and man page generation, by the way. Oh, cool. Well, the problem with this is that if we ever end up bootstrapping this to Lovely, then we're not going to be able to use clap and stuff, so I don't know how deep into that I want to get. What is this? Create TAC? It takes a checked program. Okay, so we just pass in the checked program. Well, I should probably take a reference. Oh. How's that? This should probably take a reference. No? I mean, it could just consume it. Do you need to compile to assembly, or can you do it directly into machine code? Is there a difference? There is a difference. I have no idea how to go straight to machine code. That sounds really difficult. Assembly just kind of makes a little bit of an easier step. Where was I? Here we go. Just make your own clap once you bootstrap it. Yeah, totally. I'll make my own clap. I'll call it slat. My own clap called slap. Check program. Oh, this has to be ref now. Okay, there's that. And then, oh, so we have an IR string. This is cool. So then we'll say like standard. We'll write output. What is this? Output path? No. Oh, okay, so we got a match on like the output path. Shoink. What are you talking about? Okay, wait, hold on. If so we can pass we can pass an output, or we can just print it. This is so great. Check this out, guys. So now no -o, we're just gonna print it out, except we got a to-do. Where are all these warnings coming from? Somewhere in here. This lifetime. Oh. Okay. I saw another warning. IR mod. Yeah, okay. All right, so now we can just start working on generating the TAC. TAC generation. So, should be pretty straightforward, I'm thinking. Where will we start? What's a good simple example? So checked program. What's on a checked program? Checked program dot expers. Okay. So I'm gonna say let mut blocks equal vec new, sure. And then I'm going to say for exper in checked program dot expers. And then I'm going to return blocks, by the way. And then there's that. Okay, so what is it on exper? Dot data. Gotcha. Okay. So we need to match on exper dot data. And just fill in all these. Piece of cake. We just gotta, get rid of all these. That's kind of ugly. And then import that. Very nice. Okay. Very, very nice. So then give these all the to-dos. So this would be like units. This would be like, bools. This would be like ints. This should be like idents. This should be blocks. This should be prefixes. This should be infixes. This should be var-decals, I guess. And this should be functions. And this should be function calls. So what are we hitting when we try to do this? We're hitting var-decals, which I guess is the first. Yeah, this is the var-decal. Okay. So if we have a var-decal, with iced direct binary generation should be comparable to NASM. You saying just skip NASM? Okay, that's a side quest. NASM for now, definitely though. Yeah, I agree. Should I what all becomes a block? Like, do I start with some sort of like entry block? Do like a block expression? Well, the problem is block expressions. Okay, yeah, no, I can get on board with that. How about a block expression with 2 plus 3 inside of it? Okay, so now we got a different thing, not implemented blocks. And then go to this guy, and we just work on this. So blocks comes with some expers, right? Yes. And then we pretty much are just gonna say you should keep track of a current basic block. Wait, I don't really need that quite yet though, do I? Wait, I got I got questions. This needs to be renamed. Wait, what's wrong with this? Okay, can this be create TAC? This should be like a program IR, something like that, I guess. Oops, this should be down here. And then do this, and then have another one here. Okay, I did this wrong. This should be pub fun expression IR, which is this. This should not be that. This should be checked expression. And then this actually just calls out to blocks.push that, right? Move blocks to the struct, make it a field. Oh, so that I don't have to worry about that. That makes sense. That does make sense. Yeah, gotcha. Basic block. And then do that, and then I can do this. Well, this will actually do that. Okay, but this won't. Yeah, I can't move out of this. How can I do this? Oh, they just push to the current basic block. That makes sense. Okay. So we will keep track of that. But how do I want to like return these blocks, no? I probably don't want to clone them. Unless I say that this consumes self. Just do that. Don't return it. Well, wouldn't this be a little cleaner? You're saying don't return it, just have them like reach for it off the thing afterwards? Which style is nicer? Alright, I'll go with this for now. The old checker API style you don't like? I don't really like my checker API style either. This guy? Oh, the old one. Like where the type errors went onto here. But these still go onto here, which is sort of still kind of janky, I feel like. Well, I did sort of change it. The type errors don't go on there anymore, but these still do. It's kind of janky. Yeah. I don't really want to do that here. I'd rather, if it were up to me, which I guess it is, I'd do this. You guys really don't like this style? Jappy, what do you think about this style? You're kind of good at Rust, or really good at Rust. That's good to you? Yeah, I like this. I think I'll do this. And then I'll probably go back and change the checker later. Okay, so then yeah. So block is gonna make its own new block. Right, so we have expers. So we do need like a current block. So I'll make like a block ID. Okay, so then this, we'll make a new block. Right, and we'll say, let ID you need an index to the current block. What do you mean by that? These will be indices into this into the blocks, right? Back patching jumps. Wait, what? Can't I just use self.cur or here? Oh, like this. That's what you meant. Do I start off with one block? That's like the entry, maybe? Yeah, I'll make helpers like append instruction. That's good. But do I start with one block? Those of you in YouTube chat asking about the lecture and the parser being 2 steps, like pull up. Currently it's 1 step. Like the parser just grabs the next token from the lexer. Yeah, the lexer runs as needed, exactly. Start with an empty basic block. Okay, we'll start with that. So we'll call this thing entry. Well, it's not really the entry because the entry is going to be the main function, right? So it's more like Well, I guess it is the entry, sort of. ToString. Look at this example from Runestone. This thing? Append basic block. Oh, you did call it entry. Gotcha. Which sets the current basic block. Gotcha. Yeah, that makes sense. Okay. So then we start with a basic block called entry. Instructions is an empty vec. You can just create all the basic blocks up front. Okay. Let's just try this and we'll figure things out as we go. So the new block ID will be like the length of that, and then we'll say I'll make a little helper guy. Add block. Mut self. Oh, this will return. Yeah, this is good. Okay. Mut self, and it'll take name, the stir. This isn't what I want. And then it will return a block ID. You create the new block, and then you push it, and then you return. Yeah, this is perfect. Okay. So I'm going to say new block ID equals add block. It needs a name. This needs to be mutable. And then generate a new name. Yeah, how do we want to have a new name? Block expr, and then some sort of like number in here. Like this could be can I just do like this? That'll be unique. I kind of like this way. So now we have a new block, and then we're gonna go into this thing. So we'll say like self dot current block is the new block ID, and then Chappy, you're very confused. I need a new block, right? All right, and then I need to. I thought I was appending to the current one. No, but when I have a block, this is for block expressions. Block expressions need to be their own block, right? Oops. Oops. Because they also like return a value out of them. No, I don't think it's in a control flow situation. Okay, so then for all the exprs in it, I'll say, yeah, for expr, do that in our new block. Just generate all the expressions, and then I need to like return the last one. How can I do that? I need to return the last one. And also restore the previous current block at the end. Good point, Xavier. Yeah. Because basic blocks don't return anything. But they need to return something, don't they? Like they have to have a terminating block at the end, like either like a ret or a goto, no? So I need some concept of like a ret. And how do I get said value? Treat them like functions? Yeah. That's kind of what I'm saying. So it's just a matter of what do I return. Well, first I need to go make like a ret command. Ret entity. Add another layer on top of the blocks. Wait, why? I'll just return an entity from that function. Blocks never ever return anything, but a basic block returns something. Well, it either ends in a goto or it returns something, right? So can't I just get okay. Blocks are just labeled vectors of instruction, but doesn't the last instruction in a block need to be ret or goto? Like something that diverges? Yes. Yeah, exactly. Jappy, are you talking about basic blocks or like block expressions in the language? Because they have values. Basic blocks. Okay. So then what are you suggesting then? Oh, you don't restore the previous current block? Okay. So what is being suggested? This block, I'm making a basic block here, needs to end in some sort of ret, correct? This is correct, right? I need to end in like a ret, and then the value of this last expression. Anytime you said block, you mean basic blocks. Yeah, no, I think I got that. Ret's only for returning from a function? But then how do you get like the value that... Ret is only for a function, that's fine. But you do get a value out of a block. Wait, you mean now you mean a block? I'm talking about block expressions. I'm listening. Treat block expressions like lambda functions. Okay. How? Yeah, without any parameters with an inferred return type. That makes sense to me. That's literally what they are. They're just like ifs, right? So then how do I deal with this? You're saying I need to, if I'm treating it like a function, right? Then I add functions to the IR. What do those? Add a call instruction. Isn't Is there an example on like the Wikipedia? There's not an example on the Wikipedia page of what functions look like, right? Wouldn't a function just be a block that ends with a ret, right? They have a name, params, return type, and a vector of basic blocks. So you're saying like pub struct function. Okay, then what's the entire IR? Is it the entire IR? What is it made up of? Functions or does the entire thing just end up being one giant function? So it has a name, which is a string. It has a return type, which is a type, right? Okay. And then you do